Hi everyone, the lesson 3 for Tuesday week 1 maths, the last lesson for the day, unless you want to go on and do some of those fast finishes and interactive activities. Jumping back into Ed Studio, we'll go up to the maths folder and into Mathmentals week 1, where you can download the PDF with the math mental questions for the week. And here we are on Tuesday, so if you could please head up your book if you don't have this sheet printed out. Week 1, Tuesday, 21st of April, and I'll make this screen bigger. (2020). Actually, you don't have to put the old there. 21st April 2020, and we are doing math mentals. And of course, please don't forget to put your name at the top so that when it's photographed and sent through and I put it in your folio, it's very, very clear whose work it is. Okay, so straight into it, we're on to Tuesday. So have a look at the clock now, time, and write that time in digital time. The next one is draw a reflection. So if you look into a mirror or you hold something up in a mirror, it's going to have the reflection. So if we took this symbol here and we held that up in a mirror, it would reverse it. So what would this say? And remember, you can pause and write your answer and then come back and correct it. And the answer is, if you reversed it, you go this side first, so 43. So this is round 2 and 7/10. So don't forget, if we have an item, we've chopped it up, a square or a circle, and we've chopped it up or sliced it up into 10 pieces, and 7 of those are coloured in. That is mostly that circle, isn't it? So we're on our way to 2 and mostly another whole one, so that would be 3. So what is the radius of a circle if its diameter is 5 centimetres? So a diameter is the whole circle from one side to the other. So the diameter of this circle is 5 centimetres. A radius means it's half of the diameter or half of the circle. So half of 5 is, well, 2 plus 2, and then there's 1 left over, so we split that 1 into half and it's 0.5. So write that down, what a radius would be, and this would be 2.5 centimetres. Okay, halve 500. So if we're going to halve something, we divide it by 2. So we head that up, put the little box around 5 and put 2 on the other side. If you know how to do that, go ahead and do it. 2 into 5, 2, 4, that's 2 and 1 over. 2 into 10 is 5 and 2 into 0 is 0, 250. 16 equals A, which this is algebra, it's a symbol, and it's basically asking us, what does A mean? What is its content? So A plus 8, what do we add to 8 to get to 16? You can count that on your fingers, or if you know your 2 times table, write it in. So A here, A equals 8. 8 plus 8 is 16. Now this is a really good one to go with for our BODMAS that we're learning this week. So we do the brackets first and we do multiplication, so we can do either side, it doesn't matter. 5 times 5, count that up on your fingers and write it above the bracket. I can't emphasize that enough. With these bracket ones that you do, write the answer above the bracket, because then you're going to take that answer and add it to the second bracket. So 2 times 10 is, write the answer there, add those together and write it in. Diagonal means anything on an angle that way. So how many diagonal lines can we draw on this square? So draw a square on your page and draw them in. Remember, they have to be diagonal, not straight. The lowest common denominator for 1/4 and 3/10 is 10, 15, 20 or 24. So it has to be the lowest number and a number that both 4 and 10 fit into. Can they both fit into 10? Can they both fit into 15, 20 or 24? So write your answer there. And of course 4 can't go into 10, 4 can't go into 15, 4 can go into 20. So the question is, can 10? Okay, so question 10 is, what is the perimeter of an equilateral triangle? Now, equilateral means even. So I'll try and draw an even triangle with 3 equal sides, and each side has 7 centimetres. Now remember, the perimeter means that if we are to run around the outside of that, so if we ran 7 centimetres that way, because we were really tiny, 7 centimetres that way and 7 centimetres that way, what would that equal? What would be the perimeter? So you're adding those 3 sides. Okay, the next question, Roman numeral. C, what does that equal? That's a really easy one to remember because a century, we're in another century now. How many years are in a century? So the C must mean that it equals 100. 47 plus 97. Now you can do this horizontally. You can go 7 plus 7 is 4 and put the 1 over here and then add those 2 and write it in front. Or you can use a strategy and say, I'm going to make this a friendly number. So I'm going to round this 97 up to 100, which means that I have to take 7 off here. So 7 take away 3, because 97, 98, 99, 100, 3. So 7 take away 3 is 4. So 44 plus 100 is 144. So what we added onto this side, we took off that side. We're place value of 8 in 82,411. So what does this 8 represent? Now, first of all, you'd write it down. Then this would be a 0. Then this would be a 0, 0, 0. This 80, it's telling us. I love numbers because they tell us what they are. 82,411. Okay, so name this shape. How many sides does it have? A bit tricky to count. It's 10. If you're really clever, you could look up a 10-sided polygon, and you can pause me while you do that, but it is called a dodecagon, a dodecagon. So D-O-D, dodecagon. Okay, and we could probably look up the etymology of that word, and but I'd say it's Latin, and it would probably mean 10 sides, but or the quality of 10. So the next one is double 27. So there's a couple of ways we could do that. We could multiply 27 by 2, because that's how you double something. So we could go 2 7s are 14, write down the 4, put the 1 above the 2, 2 2s are 4, plus 1 is 5. Or we could say that this is 30 and double 30 because it's a friendly number, that's 60. And then we have to take 3 off for the first 27 and 3 off for the second 27, that's 6. So we go 30, take away 6 and write the answer in, and that would be 54. Now, this is one of those wonderful thinking questions. If 1 centimetre cubed, okay, so you've got 1 centimetre, and that 1 centimetre is 1, 2, 3. So it takes up the space of 1 centimetres times 3 in an area, laying it flat. So we've got 1 millimetre cubed of water. That's the volume of water, and it's flat. And we disperse it. If so, space, 1 centimetre dispersed over 1 millimetre of water, it spreads it out. Okay, so how much water would 100 centimetres displace? If we put 100 centimetres cubed on top of something and we spread it out, how much water would that spread out? 1 millimetre did 1 centimetre. Now we've got 100, so it would displace, it's the same ratio, 100 millilitres. If it was 200 centimetres, then it would displace 200 millilitres, if that makes sense. Okay, so $5.50 plus $6.50, Really easy. We add the dollars first. 6 and 5 is 11. Do our decimal. Oh, but there's 2 50 cents, and we know that when we add those 2 50 cents, that's another dollar. So the answer is 12. Write 1,000,001 as a numeral. Yesterday we wrote 1,000,000, so continue to do that now. 1 with 3 zeros, then another 2 zeros, but it's not just 1,000,000, it's 1,000,001. So we have a 1 in the ones column. 105 divided by 5. I like to show you the divisions because I know that we're still getting used to it. So by the way, if I've given you a chance to write that, so 1,000,001 looks like that, with a 1 in the million column and a 1 in the ones column. Okay, don't forget this is ones, tens, hundreds, thousands, tens of thousands, hundreds of thousands, and then that's your million. Okay, so the division, 105 divided by 5. 5 goes into 1. 5 goes into 10 twice. 5 goes into 5 once. So the answer is 21. And the last one is 4 times 3/4. Now, as we know, when multiplying fractions, we don't change the denominator. So 4 goes over 1, and then 3 over 4. We times the top. 4 times 3 equals 12, and we just keep the denominator the same. We can't use that answer because that's what we call an improper fraction. The number at the top is too big for the number on the bottom. So we say, how many times does 4 go into 12? Count that on our fingers. 4, 8, 12, and the answer is 3. And that's our mental maths for today. Make sure you've written that down clearly so that I can mark it and send it in to me for 5 stars. Now, let's get going on to our focus for this week, which is BODMAS, which is actually a really important concept and not that hard once you get your head around it. We did our PowerPoint yesterday and you watched the video. Today we're going to double click on the booklet and go in and complete some of the booklet, not all of it today. And I have 2 of those booklets open. Okay, so BODMAS. Just going through the booklet and we'll work that together. The first page says you need calculators. Now, if you don't have calculators, that's okay. I'll explain to you why they've said to use that, and I'll also explain to you how to work it out both ways. So if we're given this question, write out the answer to 3 plus 5 times 5 equals, right? So if we did that from left to right, it would be 3 plus 5, which is 8, and 8 times 5, which is 40. That's one answer. But if we do it following the BODMAS, and don't forget a scientific calculator is already set up with BODMAS in it as a formula that's programmed, and you can get one off your laptop and use it. It would straight away follow brackets, order of operation, division, multiplication, addition, and subtraction. So straight away, it would put brackets around 5 times 5. So it would say 5 times 5 is 25, plus 3, 28. So both those answers are different, aren't they? So is there more than one correct answer? Yes. So if we use that, the answer that we got using a scientific calculator, where it follows the formula of division, multiplication, the multiplication comes first. 5 5s are 25, plus 3, 25 to 6 to 7, 28. That's what the answer would be with a scientific calculator. And on an ordinary calculator, you can do it now. If you've got one nearby, 3 plus 5 is 8. 8 times 5 is 40. Different answers. And the second one on an ordinary calculator is not correct because we need to follow the BODMAS formula. Can you write why you think the 2 calculators came up with different answers? And of course, the reason is the ordinary calculator going from this direction to that direction hasn't used the BODMAS formula that you need to do. Okay, now we're going to keep going with that idea of 2 different ways to do it, and the only right answer is going to be if you follow BODMAS. And I forgot to mention, if you could please head up your, oh, we've done that. Just keep going underneath the maths that you've done. But if you could write BODMAS, just to refresh our memories. And I'll expand the window again. Okay, this being brackets. So in a calculation, if there's brackets there, it comes first. Order of operation. Okay, so it's multiplication, division, multiplication, addition, and subtraction. So this first one is division, then multiplication, then addition, then subtraction. So that's the order of what we need to do. So you can write that up and pause me if you need to while you do it. So in the problems that they've given underneath, they've told you to do it two ways. So the first way is that you would just do it standard left to right. So for the first one, you would say 3 plus 3 times 4 equals, well, 3 plus 3 is 6. 6 times 4 is 24. That's the answer if we go just along that way, using a normal calculator. But if we use BODMAS, we would say, okay, well, there's no brackets. The first order of the operation is multiplication, so I'm going to put brackets around that. So 3 times 4 is 12. Then 3 times 12 is 3 ones are 3, 3 twos are 6, 36. So by using the BODMAS principle, 36 is our correct answer. So what I want you to do now is go through, do this one next. So do it as 20, take away 6, then times that by 2, there's your first answer. Then apply your BODMAS, which is brackets. Actually write the sum and put the brackets in. 6 times 2 is 12. 20 take away 12. That one's your correct answer. Give it a tick. 6 times 6 plus 4. You can start at the start. Maybe that one's going to be right because when you put the brackets around it, it's going to be the same, isn't it? So that one's okay because it had the multiplication first. Then here we go 48 take away 12 and then divide that by 4. But our principle says BODMAS, division comes first. So 12 divided by 4 is 3. Write that above your bracket. And then 48 take away 3, the BODMAS one's going to be correct. So you can pause that while you're doing it or do that with me. And then we'll move on to our next page. Okay, if a long sum has no brackets, like 3 plus 5 times 5, it has been agreed by mathematicians that multiplying would be worked out before the addition, even if it does not appear first in the sum. So even though this part is not first, we do that first because that's what our rule says. If a sum has a bracket as part of it, such as 4 times 5 plus 4, then it has been agreed that the part inside the brackets will be calculated first. So this is something that you need to remember. BODMAS says brackets first. So even though this is not multiplication or division, which would ordinarily come first, because it has the brackets, you do that first. And then you multiply it by 4. So this is why we need to remember BODMAS. So brackets of division, multiplication, addition, and subtraction. Any sum in brackets is calculated first. Division and multiplication are calculated before addition and subtraction. Now, don't forget, we've always been taught that division and multiplication go together because they deal with groups, and addition and subtraction go together. So what I want you to do now is go through from 1 to 6, write these sums out. So 4 times 2 would come first. You put your brackets around that. 4 times 2 is 8. Write it in the brackets above. 6 plus 8 is, write your answer. Here we've got 4 plus 4 divided by 2. We put brackets around the 4 divided by 2, which is 2. And then 4 plus 2 is, write your answer. Here 8 plus 6 minus 3. So BODMAS says brackets, order, division, multiplication, addition, and then subtraction. So here we have to do the addition first. So 8 plus 6 is 14. You can put brackets around this and then 14 take away 3 and then write your answer. 5 plus 5 times 4. Which one are we going to do first? we do the multiplication, and then we add the 5. Here, multiplication, then add the 12, 2 times 4, multiplication, and then add the 5. Okay, then we'll move on to this page. Remember BODMAS. Any calculation inside brackets must be completed before any other part of the sequence, and it doesn't matter if inside those brackets it's addition or subtraction. So what I want you to do is head this, just continue going, write it as a 1. So 20 times 3 is 60, 100 take away 60 is, write that down. Then it doesn't matter which side we do first because they're in brackets. 35 take away 15, write your answer on the top. 27 take away 7, write your answer, then add those two and write it in. So just going down, doing the brackets first, writing your answers above the brackets, and then doing the operations in the middle. And as you can see, it's not that tricky. Now, when you get all of those done, there's 2 little tricky ones that they've given you down the bottom just to check your understanding. So this is where you really have to follow BODMAS. So here, what comes first, the multiplication, so you put brackets around those. 4 times 5 is 20, write it up the top. Then addition, plus 4, then subtraction, take away 3. So you start with this one, you jump over to this one, and then you come back to that one. Here, we go straight for the multiplication again, 5 times 1. Now, it doesn't matter, we can go either way. Plus 8, then plus 3, then take away 6. And then this is the last page for today. And it's the same thing again. All you're doing is you're working out the multiplication for each bracket. Write it above it, make sure you do, and then add it. Do that one, then take away. Do that one first, then take it away from that one. And just work your way through those. Now, once you've done all those, and make sure you actually go through and you do the workings for these, we'll stop there on page 5 and we'll pick up on page 6 after that.